your name. That is your attendance for today. So let's continue. We have 59 students on the group, and we are more than this. I don't know why that is happening. Okay, we have 65. Okay, so let's continue. So today, before going to the assignment I gave you, I want us to briefly look at something that I have not paid attention to in the last classes I've been having with you guys, and that is I told you that we have what we call aliphatic and aromatic. And aliphatic can be cyclic or acyclic. Aliphatic can be cyclic or acyclic. So meaning that we have cyclic compounds. We have cyclic compounds. We have cyclic compounds. So I'm going to be showing you some cyclic compounds. So we have some cyclic compounds. And the reason why I need to focus on this cyclic compound is because some of you don't know how to name if it has to do with cyclic structure. If it has to do with cyclic structure, and that is why I'm doing my best to explain it to you. For example, if a compound is written this way, look at this compound very well. Let's imagine that this compound is written this way, and you have to name this. Now, very simple. This is, you count the number of carbons. You believe that the number of carbons are every joint on this shape, right? So this is carbon, we have 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 carbon, and we have carbon here. Now, with what I have on the board, how many carbon can you see here? You can see 1, 2, 3, 4, 5, 6. You can see 6 carbons, right? Now, 6 carbons signifies what? When it is 6, it is what? X. When it is 6, it is what? X. But because it is cyclic, that is why we are saying cyclo. So anytime your structure is a cyclic ring, a ring structure, you use the word what? Cyclo. I think that is clear. So this is cyclo. Now, it depends, because looking at this, you should be able to determine the number of hydrogen that is present on this compound. For example, we know that this is a carbon. Can you see the carbon that is here? This is a carbon. This carbon is having hydrogen up here, and is having hydrogen down here. It's having hydrogen here, hydrogen here. We have hydrogen, we have hydrogen, we have hydrogen, we have hydrogen like that, we have hydrogen like that. Now these are the hydrogens we have here, because I taught you line formula. You know that this is one bond, this is one bond, then plus this, making how many? 4, that is around that carbon that is there. Is that clear? But this is the ring structure. Because it's a ring structure, and all that we can see on this structure is just carbon and hydrogen. All that we can see on this ring structure is carbon and hydrogen. Take it to the right one so that. So all that we have here is carbon and hydrogen. So since it's carbon and hydrogen, and there are single bonds that are around it, what type of family of the organic compound is this? Alkane. Abi? So how many carbon can you count? 1, 2, 3, 4, 5, 6. How many carbon altogether? 6. And because it's a 6 carbon, so what do you say? Because it's 6 carbon, you say it's X, Abi. So I can easily say cyclo. I can easily say cyclo what? Cyclohexane. This is cyclohexane. Is that clear? So please, I want you to. Is it on the line like that? Okay. Now, this is cyclohexane, and how do I know cyclohexane? 1, 2, 3, 4, 5, 6. So if you have something like this, let's say we have something like this. How many carbon is here? 3. 1, 2, 3. Is that okay? If you have something like this, how many carbon is there? 4. 1, 2, 3, 4. 4 carbons, right? Now, and I can put any functional group on them. I don't know if you get what I'm trying to say. If you have any question, please ensure that you ask that question. I think it's clear. So, for example, if I have something like this, everybody, have you seen a compound like this? I have something like this. Now, look at this compound. Now, this compound, you know, there's a way we can put hydrogen on them. You know that now. Now, this is a carbon, this is a carbon, this is another carbon, this carbon, and this carbon. They are two. And this is also another what? Carbon. So how many carbon do we have in total here? We have what? 6 carbons, right? Now I can determine the number of hydrogen that will be here because this is carbon, 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 carbon. Now this carbon now is having one bond and one bond, and I told you that how many bonds can we have around our carbon? How many bonds? 4. So I know the number of hydrogen. So most of the time, this is where you see your compound. You don't need to include the hydrogen. The hydrogen is hidden. Is that okay? Now who can tell me how many hydrogen will be on these two guys here? How many hydrogen will be here? Who can tell me? Oh, yeah. How many hydrogen will be on this carbon? How many hydrogen will be on this carbon? I'm waiting for a response. How many hydrogen will be on this carbon and how many hydrogen will be on this carbon? There's a carbon here, there's a carbon here. How many hydrogen will be here? 1. There will be 1 hydrogen here. Then this carbon will also have how many hydrogen? 1. But this one will be having what? 1, 1. That's 2. This 2. This 2. This 2. Do you all agree with me? Yes. Yeah, that's clear. So I think we can continue like that. So if you have a compound, now if you now let's go back to this compound. I want us to name this compound now. I want us to name this compound. Everybody go back to this compound. Let's try to name this compound. Now, firstly, what can you see on this compound? You can see carbon all over, right? But there's a functional group inside this. Who can tell me the functional group that is on this structure? What's the functional group that is on this structure? Oh yeah. Thank you. Now, the functional group on this structure, the functional group that we have on this structure, I want to know. Thank you, alkene. And why is it alkene? It is alkene because of the double bond. Can you see the double bond that is there? Can you see the double bond? There's a double bond here. So if you are told to name it, how do you name structures like this? That's the question. How do you name structures like this? Now, firstly, this is it is going to be cyclic because it's a ring structure. How many carbons do we have here? We have 6 carbons. But how do we count it? We count in such a way that our double bond here, since it's just one double bond that is there, since it's one double bond, you will count in such a way that the double bond will be in position number what? 1. Position number what? So meaning I don't want to start saying 1, 2, 3, 4 because like this will be 4. Do you know? So anytime you have something like because once you want to give this double bond a number, do you know that all these carbons here now, we can give them their number, and by giving them their number, we can give this guy his number. Do you get what I'm trying to say? So how do I count in such a way that I will give this double bond a number? Because it's a functional group, I will count in such a way that it is having a very small number. So where do I want to start my counting from? From either here or what? Here, anyone. If I do here, that will be what? 1, 2, 3, 4, 5, 6. Do you get it? If I do 1, it means that the double bond is in position number what? 1. Or if I do 1, the double bond is in position number what? 1. I get it. Either here or here. But the rule is that it must be 1, 2. Did you get that idea? Eh? So what will be the name of this? This is 1. So the double bond is in position number 1. So what do we say? Cyclo-X. Because it's 6 carbon, X. You don't need to say X1 in because the double bond is in position number 1. Abi? So what do you just say? Cyclo-X in. Somebody should see that cyclo-X in. So if you have any question, is there any question around this before I give you another one, please? Okay. I'll give you another one to try now. I want us to try it because I've been seeing questions that have to do with bigger bonds and structures like that. Let's say we have something like that. Ensure you tap on the like button, please. Tap on the like buttons. Now, everybody, let's look at this question. Can you see this structure? This is not the only ring structure we have. I can give you another one. Now let's imagine we have this here and we have bromine here. Can you name this structure? Now somebody is asking that how do we count? Do we count anti-clockwise or clockwise? I told you that the first thing is that look at this compound. That guy that asked that question. Look at this compound. This compound, is there a functional group on this compound? Everybody? Is there a functional group on this compound? Where is the functional group on this compound? Okay. Please, is somebody here? Those who are asking for anti-clockwise or clockwise, first pay attention to what I'm saying. Is there a functional group on this compound? Now, what is the functional group on that compound? I need to know what's the functional group on that compound. Yes, it's alkene. Now, and I told you that anytime you want to give them position, anytime you want to start your count, because I can make any of this carbon my number one. Do you get it? I can make any of this carbon my number one, but the rule is that you must ensure that your functional group is having a very small number. Do you get that? So your functional group must have a very small number, meaning that this is my functional group. Can everybody see my functional group here? I want to start naming, because if I say this is 1, this will be 1, 2, 3, 4. It will be giving this guy number 4. Or I said 1, 2, 3. It will give me number 3. We don't want that. We want to ensure that the functional group is in position number what, everybody? 1. Is that okay? So meaning that this is our functional group, which is a double bond. Yes, our functional group is a double bond. So the next question is this. This is my functional group. I get it. Now the next question is, should I say 1, 2, or what? Should I go 1, 2, 3, 4? Or 1, 2, 3, 4, 5? Who will tell me that? Which one will be better? No. If I go look at it again, do you know that I told you that this is our functional group that have the double bond? Can you see the double bond?
Yes.
This is the double bond here. Can you see the double bond? So if this is the double bond, I get it. And I said we want to ensure that the double bond is in position number what? 1. Because it's the priority, it's the functional group, right? So how then do we go about it? I said I should count in such a way that is having position number 1. So I can start from here now 1, 2, 3, 4. Or I can start from here and say what? 1, 2, 3, 4, 5. So 1 is 1, 2, 3, 4, and 1 is 1, 2, 3, 4, 5. So if I count like this, if I make this 1, this is 2, this is 3, and this is going to be what? 4. Our bromine is going to be in position number what? 4. So do we want the bromine to be in position number 4, or do we want the bromine to be in position number 5? Which one is acceptable? To be in position number what? 4. Because in this case, our functional group is in position number 1. Do you know? But you know I can count the other way around. What do I mean by counting the other way around? I can say 1, then what? 2, then what? 3, 4, 5. So which one is better? 4 bromo or 5 bromo? 4 bromo. So 4 bromo, that will be what? 4 what? Bromo. Is that okay?
Yes.
Then what's our ring? Our ring is cyclic. Because it's a ring. I told you anytime it's a ring, what do you say? It's cyclic. Because it's a ring, it's a what? Cyclic. Are you with me? 4 bromo cyclic. Now, how many carbon is this ring having everybody? 6 carbon. So 4 bromo cyclic what? Because of this double bond, our double bond is in position number what? Everybody? 1. Not position number 2. Position number 1. 1, 2. You get it?
Yes.
Or you are looking at this? No. Because society counting for you. You get that?
Yes.
So that will be what? You don't need to say X1, you just say 4 bromocyclohexene. Now, so far, is there anybody that is having question? I have 119 people on this class. Is there anybody having question on this naming a cyclo compound? I will give you a question to name, to draw for me, and I'm expecting everybody to be able to draw that structure. Let me clean up this side. Let's bring in something else. Now, anytime you are given a cyclic structure, what you pay attention to is what type of cyclic structure do we have? Because it can be, we have different type of cyclic structure. I say it can be, this is how many sides? This is 6 sides. We have the 4 side. We have the, what do you call it, 3 side. Is that okay? We have the 5 side. But in this case, how many sides do we have? We have what? 6. Is that okay? Now, so what do you pay attention to anytime it is cyclo? Anytime it is cyclo, you pay attention to how many sides is that structure. Is that okay? Then what type of functional group is present on it? You give the functional group priority. What I say should give the functional group priority. So can somebody draw this structure for me? Can somebody name this one for me? And maybe let us make it another dimension. Hello, can somebody tell me how many functional group is present on this compound? I'm expecting an answer. Oh, yeah. How many functional group do you have on this compound? This compound I put on the body. How many functional group are you still? Then how many? Let's start with this. How many sides is this ring?
5.
5. How many sides? Let's first ask the question. How many sides is this ring? Oh, yeah. 5. Let's count. How many sides? I mean side of the rings. That's 1, the 2, 3, 4, 5. 5 sides. Now, how many functional groups can we now see there? How many functional groups are you seeing on this? 2. Yeah, I think some people, yes, you got it right. We have 2 functional groups there. Where are the functional group? We have this guy. This is one functional group, right? Then this and that what? Functional group. How many functional groups do we have in total like that? 2. We have 2 functional groups, and this is how many sides? A 5 side. And because it's 5 sides and it's a cyclic, you see cyclopents. Abi? Cyclo what? Pents. Cyclopents means is a ring structure that have how many sides? 5 sides. That's why I call it a what? A cyclopents. Now the next question is, what type of functional groups do we have on it? Now I want to test your knowledge on functional group. I thought I am very sure I taught you functional groups, right? Now let's start with, what are the functional groups on it? We believe it is 2. This is one functional group, this is one functional group. Let's start with, what are the functional groups on it? Tell me the names of these functional groups. Where are they coming from? Oh yeah. How are you? It's been a while. Did you attend classes? Now, yeah, we have some of our students that is attending the physical class here. So in case you want to know, we have some of the students attending the physical class. So shout out to the physical students here. Now, look at the board again. What are the functional groups that is here? We have OH. Somebody is helping me. Who is that person? Tofumi. Tofumi said we have alkano and alkano. Please clap for that girl. It's not easy. It's not easy. Yes, we have 2 functional groups here. We are the functional groups. The functional groups are OH and double bond O. We have OH, which is alkano. This guy is coming from alkano. Then this double bond O. Where is this guy? Where do you think this guy is coming from? Because some of you don't know. Where? Pass find that way. How do you know it's alkano? This is like saying, this is alkano. How do I know? It's like saying, see. It's like saying this. Do you remember R? Remember? This is functional group of ketone. So who did not know that this is a ketone functional group? If you did not know, let me know. So I'm student Jegede Samuel, thank you so much. Angela Odua, thank you so much. Who else again? Oyedepo Barakat. Good girl. Good girl. Now, the next thing is, how do we then name it? Abi? So the next question is, we have 2 functional groups here. Okay, I have seen it. We have 2 functional groups here. This and this. Who is taking priority? Who are we going to give priority? That's the next question. Between OH and a ketone, who will have more priority? Oh yeah. Were you there when we did our hour? I've not been seeing you this semester. What's going on?
I know that then staging class like that.
Why? When did you start now? Is that?
I didn't
late. Okay. Have I seen you this semester?
Yes.
You attended math class?
Yes.
You come and tell me why you have not been attending class after the class. Is that okay? Now, let's continue. We have some physical students here, so don't worry. Now, who is having more function? Who is having more priority? OH or ketone? I'm waiting for answers. Ketone. I've been seeing ketone. Yes, good girl. Ketone. Sebastian. Ketone. Who else again? The priority we give, yes. Oh, Ayodeji. Yes, thank you. Yes, Angela Lua. Yes, ketone. Thank you. The one who will be giving priority to the most is ketone. Is that okay? Now, if ketone is the priority, then how do we go about it? If ketone is the priority, who are we going to give position number 1? Because we have 2 functional groups. Are you getting it? We have 2 functional groups. So who are we going to give position number 1 to? Because the functional groups are the one that should have this. Are you getting it? So you don't want, because these are many carbons. These are 5 carbons, right? And you want to start naming, right? You want to start giving them number. You want to give them number in such a way that they are very, very small. Abi? So if you want to give number, you start giving number 1 to this, 1 to this, 1 to this. No, there's nothing here. Now what's the hydrogen? So who do we give position number 1? This ketone or this OH?
I've attended is incorporated.
Okay. Who are we giving priority to? OH or ketone? Ketone, right? Yes, we are giving priority to ketone. So meaning that this guy will be in position number what? 1. Are you? Should you say we should give priority to ketone? Yes. So our carbon here, this carbon here will be carbon what? 1. Are you with me? Yes. You know there are 2 functional groups. Because the question you might be asking me that, why can't we say this carbon is carbon 1? No. Why can't we say this carbon is carbon 1? No. I said we have 2 functional groups. It is those functional groups that we give priority to ensure that they are very small. Is that okay? But in this case, we have 2 of them. So is it that we give 1 to this or we give 1 to this? Is that okay? So who are we giving the 1 to? This guy. So if this guy is number 1, bam, we now have to start counting. Either we count in clockwise manner or what? Anti-clockwise manner. Are you with me? We are counting in what? Everybody? Clockwise manner or what? Anti-clockwise manner. If you are counting in anti-clockwise manner, let's go. This is going to be what? 1. This is going to be what? 2. And this is. Somebody say why ketone? Ketone is giving more priority because if you check, ketone is having. Let me tell you guys that are having more priority than ketone. Carboxylic acid is having more priority than ketone. Who else again? Esters, carboxylic acid and its derivative, alkene and ketone. What I say again? Alkene and ketone are having priority more than what? OH. Is that okay? If you have been attending my class, I said it. Oyebanji, alkanone, carboxylic acid, they are higher up. If you see the way they gave you the trend of the families of the organic compound, you will notice that they gave you alcohol, then after alcohol, they move to what? Alkane and alkanone, then after alkane and alkanone, they now move to what? Carboxylic acid and its derivative. So those who are asking that question, is that clear? I believe that is clear. So, yeah, you can keep tapping on the like button, please. Tap on the like buttons. Thank you so much. For those who are enjoying that class, then ensure, if you have not subscribed, ensure you subscribe. Tap on the like button, yes, so that and ensure you subscribe so that you can get notification on classes like this all through the break. Is that okay? So tap on the like button, subscribe. If you are enjoying the class, just subscribe and ensure. So let's continue. So OH, this ketone is giving priority number 1. We all agree now. So this is 1. Now the question is, should I count? This is anti-clockwise, or should I count what? This is anti-clockwise against the clock, and this is what? Clockwise. So my question is, should I count 1, 2? Let me use the letter. Should I count 1, 2, 3? Should I count 1, 2, 3? Or should I count 1, 2, 3, 4? Which one will be better?
1, 2, 3.
Why are we going for 1, 2, 3 anti-clockwise? If I do 1, 2, 3, 4, OH should be in position number what? 4. If I do 1, 2, 3, OH should be in position number what? Everybody? 3. So what do we want? We want it to be in position number 3 or position number 4? Position number 4. So if this guy is in position number 1, by counting 1, 2, 3, OH should be in position number 3. But if I go this way, 1, 2, 3, 4, OH should be in position number 4. So we want to ensure that our functional group or substituents are the smallest possible number. So what are we going with? So 1, 2, 3. Is that okay? So the whole thing is how many carbon? Everybody? 5. So anytime it is a cycle, we say cyclo, abi. So roots, the major name will be, the parent name will be cyclo. Is that okay? They will now say pens, what? Because this guy is already in position what? 1. Abi, pen, tanone. Pentanone means that guy is in position number what? This guy, I mean, the alkanone is in position number what? 1. Now, what do we now call our OH? What I say we call OH. If OH is not giving priority to, what do we refer to as? What do we do with OH if OH is not giving priority to? Who remember that? If OH is not giving priority to, what do we call it? It will be hydroxyl. So because OH is not taking priority now, it is not going to be bearing the name OR. It is going to be bearing the name what? Hydroxyl. Who remember that? So this is going to be hydroxyl, right? So what then do we call this? We then say what, everybody? What position is this hydroxyl? 1, 2, 3. That will be 3 what? Hydroxyl what? Cyclopentanone. 3 hydroxyl cyclopentanone. Yes, 3 hydroxyl cyclopentanone. Does anybody have any question before I give you? I have a question for you that you will name for me. I have a question for you that you will name for me. I have a question for you. Alkene and alkanone, who has priority more? Alkene has more priority than alkanone, even though they are almost the same. But most times you rarely see them putting them together in a compound. But sometimes you can find them together on a what? Compound. That means a compound can have both alkanone and what? Yes, alkanone and alkane. Any more question? What about the alphabetical order of the naming? Somebody is asking for alphabetical order. And it's very simple. We said 3 hydroxyl. Hydroxyl. This is the what we call it, the prefix now. Is that okay? We don't have more than, the only thing we have here is OH. Is that correct? So there's nothing like, this is the, what's the parent's name, everybody? The parent's name is what? Cyclopentanone. What I call the parent's name? Cyclopentanone. This is just the prefix. So I think that is clear. Who is having more questions? Can we move on to the next thing? Now I have a question for you. I'm coming. I have a question for you. I need somebody to help me name. I think I sent some questions to the group that day. You people, I don't know if you saw the question, but I just have a question for you. You help me name this compound. I have a question for you. So please, a minute, we are addressing something. Just they want to lock this place and take the key to office there. Sign it out back and bring the key. So now I have a question for everybody. So wait, I'm coming. Sorry for the break in transmission. We're addressing something. Where's the question? Oh, okay, I think I've seen it. Now, who can give me a structure give me the structure, everybody give me the structure of cyclo, write the structure of cyclohexa 1,4 diene. Give me the structure of cyclohexa 1,4 diene. Give me the structure of that compound. Cyclohexa 1,4 diene. I need the structure of that compound. Oh yeah. Those who are asking, they can rewatch it. You better start watching it now. I might not upload it to. Start watching it. I don't know why. Some of you are playing at home. Some of you are eating. Pay attention to what I'm doing. It's very, very important. I know it is not easy. There's no data. Me too, I didn't have data. So we have cyclohexa 1,4 diene. Keep tapping on the like button. Now, are you done with the diagram? I think, how can they send the diagram? Can they send the diagram? I don't think they can send the diagram. They can't send the diagram. But can you not draw this? Maybe that will be an assignment for you. Some of you cannot draw this. Oh yeah, let's draw. Cyclo, let's draw this. Cyclohexa. What does cyclo mean? Cyclo is a ring structure. What's the meaning of X? X means how many sides? 6 sides. That means the cyclo we are drawing is how many sides? 6 sides. So 6 sides will mean 1, 2, 3, 4, 5, 6. This is cyclohexa. Do you all get that? Cyclo what? Hexa. Now they now said 1,4 diene. What's the meaning of 1,4 diene? The guy is having how many? 2 double bonds. One in position number what? 1, and the other one in position number what? 4. One in position number 1 and one in position number 4. So you can take it from anywhere you want to make your number 1. Do you get what I'm trying to say? So we can, because this structure can be different for everybody, but the question says is cyclo Exact. 1,4. 1,4 means you can pick it. Your double bond, one is in position number 1, and the other double bond is in position number what? Everybody 4. Meaning that you can pick your number 1 from anywhere, then count it to 4. Is that okay? So where do you want to pick our number 1? Some people can pick theirs here, they are pick theirs here, pick theirs here. That's why this structure will be different for different people drawing it. Is that okay? So I can put it here, I can put my number 1. So far you have your number 1 first, then you reference it to the 4. Is that okay? So for example, let's say we use, where do we want to use? Should I use here? Should I use here? I can use any part for my number 1. Do you get it? Let's imagine that this is number 1. Can you see number 1? So this is what? 1. You can count. Another thing is that anytime it is double bond, you have to count 1, 2. What I say again? Do you get what I said? That means you don't say 1, 2, 3, 4. Anytime you have the double bond, that is how do I say you count? 1, 2. What do I mean by 1, 2? 1, 2, or what? 1, 2. Do you get it? So this is 1, 2. Like this, you are going like this. Right? Or the other way is what? 1, 2. You are going like this. Is that okay? So this is 1, 2, 3, 4. So where would I put it? Here. For another person, you say 1, 2, 3, 4. It's still landing there. I think that is clear and correct. Are you here for the chemistry class? Okay, you can have your seat. So, do you all get this? Everybody? No, we are having the class both online and physical. So, I'm going to be addressing you people and I'm going to be addressing them. Is that okay? So, if you do not understand, ensure you come attention. Now, what we usually do was we try to name some cyclic compounds, because the reason why you have to know all this is because if you are dealing with questions, they will call out the name of those compounds and you are expected to be able to draw it. If you cannot draw it, we fail in that part. Is that okay? Yeah, thank you. So, I think that is clear. Is anybody having a question? Is anybody having a question online? If anybody having a question, we just started. What I did was just a quick revision on how to name the cyclic compound. Ensure you tap on the like button. Ayomide, please, can we download the class and watch later? I might not upload it, but let's just see what we have. I might decide to upload it, but for now, just join the live class. I can see some people asking me that question. Now, if everybody understand that, can I give you a compound to name? Yes. Try this and let's move away from this and go to next thing. I want you to try this. Try this. Why have I been using this cycle? This is cycle. Try this. Let's imagine we have OH here. We have COOH. Then we have CO. And this BRA. Now, I want somebody to name this compound on the board. Try to name that compound. Everybody, try to name that compound. And let's leave this naming on cycle alone. Name that compound for me, please. Diene. Somebody is asking about diene. Diene means two double bond now. Diene is a functional group. Diene means a double bond. Diene means two double bond. These are the two double bonds. Can you see? This is cyclohexa. Hexa means 1, 2, 3, 4, 5, 6. That's the meaning of hexa. Is that okay? Then there is a cyclohexa 1 for diene. In means alkene, right? So they now say 1,4 diene, 2 double bond, one in position number what? 1, and the other one in position number what? 4. That's the meaning of that. Then try this naming. I'm waiting. Oh yeah. I repeated it because some people were asking that they didn't get it. So, oh yeah, let's try this name. Who is the priority? Yeah, this is how many sites? This is 6 sites. Now, which of them? How many functional groups can you see here? Functional groups. COOH is a functional group. Do you agree with me? This is a functional group, right? OH is also another what? Functional group. right? Then what else can you see? Then we now have the words. This is one functional group, this is one functional group, right? BR is not a functional group, it's just a substituent. Is that okay? Now the question is that between COH and OH, which of them is having more priority? COH, Abi? Because COH is having more priority, then how do we name this compound? That's the question. How do we name this compound? Don't let me make it more complicated. Let me do something to it and make it easier. This is C, okay. Then let's leave it like that. Now, I want you to try this naming. Do it and send the answer to me. 4-bromo, 4-hydroxy, cyclo, hexanoic acid. Okay. Just try. Somebody should try it. I want people to try that question. Try that question. Try that question. Try that questions. 2. Now, this is the major priority? Do you know this is major priority? Let them try that. Let me give it out as just an assignment because I've given you a lot of questions. So let me move to the next thing so that I won't bore you with much of this naming. We have been doing, for those who are just joining, we have been working on naming cyclic compounds. Is that okay? I know many people are familiar with straight chain, linear compounds. But sometimes your question can involve that you know how to draw back the cyclo compound. Is that okay? And I've done that. So I want us to move to where we stopped in class. I don't know, maybe some of you where we stopped in class was on, we're looking at boiling point, melting point. But let me do something today. Everybody write now. If you are my student, your tutorial notes, you don't need to write in your tutorial notes, just write this separately somewhere, because I'm not going to continue from where I stopped from the tutorial. I just want to give you some things that are relevant that can make you solve some question from your past question now. Is that clear? So write stability of alkene. Just write stability of alkene. Oh yeah. Stability of alkene. Stability of alkene. Somebody writing that. Stability of alkene. Stability of alkene. Everybody writes stability of alkene. Stability of alkene. Stability of alkene. Now, let's look at stability of alkene. Stability of alkene. Now, questions comes out on this particular year, and I want us to quickly address it. Everybody know an alkene normally, they are the guys that have double bond. You get that? Now, what is the stability of alkene? They gave us several stabilities, and these are the stabilities. Number 1. The stability of alkene means which of the alkene is more stable. And what can make alkene to be more stable is alkene that have more substituted alkyl. What do I mean by that? For example, where is the man in there? Should give me ink and marker. So everybody look up. So we have C, we have C. Can you see? Now, we have R, we have R, we have R, we have R. Now, this is one type of alkene. And then R is what I call R called alkyl. You get alkyl here is their methyl, ethyl, and the likes. Do you get that? Now, this is an alkyl. Is that okay? These are alkyl groups. Now, how do you know the alkene that is more stable? The alkene that is more stable is the one that have more substituted what? Alkyl. Is that okay? How many substituted alkyl do we have in this compound? 1, 2, 3, 4. We have 4 substituted alkyl. Is that clear? I'm saying it again. Stability of alkenes. That is what we are doing. Stabilities of what? Alkene. The more substituted your alkene, the more stable that alkene. Is that clear? Now we are going to attempt a question from your pack. So be ready. I don't know if some of you have your past question yet, but I'll try to see what we can do. Now, the more stable, If your alkene will be stable, it will have more alkyl group. So write it down. Write it down. The more alkyl group, hey, where's manager? I need to come and change this thing. The more alkyl group, the more the what? Alkyl group. I need that black. I don't know what is wrong with it. The more the alkyl group, the more stable the alkene. Everybody should note that. Write that. The more the alkyl group, the more stable the alkene. Is that clear? The more the alkyl group, the more stable the alkene. Now, what are alkyl groups? Alkyl groups are what? Alkyl groups are methyl, ethyl, and the like. And propyl. Is that okay? Now, let's compare this guy to this guy. Now, everybody look at these two compounds. Who is more stable between the two of them? Compound A and compound B. Who is more stable in compound A and compound B? Compound B. Compound A. Why is compound A? Huh? You have not okay. Who is more stable, compound A or compound B? Compound A. Compound A is more stable because it has more alkyl group. Is that okay? This is 1, 2, 3, 4. Right? Sorry. This is 1, 2, 3, 4. It's just like having something like this. Maybe as you draw, it's just like having something like this. Just like having something like this. CH3. Something like this. CH2, CH3. And something is having CH3. And then we have CH2, CH3. Now look at it. This is the carbon here. This is the carbon here. So how many alkyl group? How many substitutions do we have there? We have 1, 2, then we have 3, then we have 4. So because if it is 4, it is not what? It is not substituted and it is not stable. Now in chemistry, anything that is stable normally have less energy. Like that. Any compound that is stable, everybody should put that down in your notes. Any compound that is stable will have a lesser energy. Put that down in your notes. Every compound that is stable yes, every compound that is stable will have less what? Energy. Is that okay? So if I ask you that now, between compound A and compound B, who is more stable? You said compound what? A is more stable. Why is compound A more stable? Because it has more alkyl group, right? Now, they can ask you a question between compound A and compound B, who has the lesser energy, the least energy? Compound what? A. Why is compound A having the least energy? Because it's the most what, everybody? It is most stable, right? I'm saying it again, put it down. Any compound that is stable will have a less energy. Why compound that is unstable? What do you think will happen to compound that is unstable, everybody? They will have high energy. Is that okay? So, everybody is with me, okay, thank you, you are following. Now, I need black marker. Don't remove it down, now it's still in. I just need black marker. Let me find a way to work on that black marker. Now, everybody come back to the class. Let's see again. Okay, let's see another dimension. C, R, H, and H. This is tetra substituted. What's the meaning of tetra substituted? 1, 2, 3, 4. How many alkyl group is there? 4. This guy is what? Is tri-substituted. What's the meaning of tri-substituted? 1, 2, 3. 3 alkyl group, right? But let's look at this compound C. How many alkyl group is in compound C, everybody? 2 alkyl group. You can see 1, 2. Abi, this is di what? Substituted. Now, this one is greater than this one. This guy is greater than this guy. I guess it. And this guy is greater than compound what? C. Is that okay? Now, let's go to another type of dimension you can have. And what's that dimension? This compound C is greater than compound like, let me see. We did be able to see that. Okay. And you have C double bond C. You now have we have R, we have H, we have R, then we have H. We have something like this. Then I'm coming. I think we have 3 of them. We want to use this to attempt a question. I have a question for you, and that question, if you understand this thing very well, you will get the question immediately. So I want you to get it well. I'm looking for something. Okay, trans. I need trans. Now, everybody should be familiar with something like this. When we get to isomerism, you'll be familiar with it. This is a trans. What do I call it? Trans. When we get to isomerism, you understand. We have trans, isomerism, and we have what? Cis. Is that okay? This compound and this compound, what do you notice about them? They are both disubstituted. Do you know? Yes. That means they both have 2 alkenes. How many R do you have here? 1, 2. But this compound is also having how many? 1, 2. They both have the same alkene group. Is that okay? But if you see this guy is more stable than this guy. Why? Because the 2 alkene group are on 1 carbon. Do you get it? The 2 alkene group are they on what? On 1 carbon. Are you with me? Thank you. But in this case, what happened? Are the 2 alkene group on 1 carbon? No. They are on separate what? Carbon. And it is giving us what type of vibe? It's giving us a what? A trans. This is a trans. Do you like it? If you have a trans, you know we can also have a cis. Let me show you a cis. Now, this trans structure is greater than the cis structure. How does the cis structure look like? Everybody write it. The cis structure is looking at what? R, I'm calling C. Let's imagine we have H, then we now have what? R, then we now have what? R. Now, this trans structure is greater than the more stable. Okay. The trans structure is more stable than the what? Cis structure. So let's go over it again. What have you learned about stability of alkene before I bring in a question, a practical question? For stability of alkene, I believe everybody is writing. Oh yeah, write down, write. I want to clean this board. Write. We have 123 students joining the live, and we should be more than this. I don't know what happened to them. Click on the like buttons. Ensure you click on the like buttons. If you have not subscribed, ensure you subscribe to the YouTube channel so that you can get more access. Oh yeah, everybody, we have compound A, compound B, compound C. We have C, then we have D, then we have what? E. Now, what is the code again? The code is that we are looking at stability of alkene. How can alkene be more stable? The one that is having more alkyl group will be more stable. In the case of compound A, how many alkyl group do we have? 4. 1, 2, 3, 4. Very stable. Abi? Compound B, how many do we have? 1, 2, 3. Tri-substituted. Abi? So this should be more stable than this, right? Because this is having 3 alkyl group, 1, 2, 3, and this is having 4. Now let's go to compound C. Compound C is having how many? 2. This one is having 3. That's why it is more stable than this one that is having how many? 2. This is having 2, and the 2 alkyl group are on what? 1 carbon, not on. Is that the 2 of them are on just 1 carbon? Do you get that? Then now for the trans is 2 alkyl group, but it's in a trans structure, and each of them are on separate carbon. Is that okay? Then the cis, what happened to the cis? The cis is having 2R. Also on separate carbons, Abi. Trans and cis, which one is more stable? Trans structure is more stable than what? Cis structure. Now, let's now move to solving a real question. I call this R in case you see R, maybe you don't know the meaning of R. What does R means? Let me just make it easier for you. R means anytime it's attached to C, do you get C? C means carbon. What I call C? Carbon. Every alkene we start with a carbon and should be. So anytime you just look at your carbon, you look at that, is it connected to a carbon? Now what you are just looking for. Is it connected to a what? A carbon. Do you get that? Because the question they gave, that question was not looking as something. I'm going to write out those questions now, and we are going to solve it together. Is that okay? Now, let me clean off this. Let me clean up this. Give me that past question. Somebody should give me a past question. I believe you have all put down these structures that we have here. Give me the past question. Thank you. Let me give you a question from the pack. Just a minute. Let me give you a question I saw that I think we need to look at together. Just a minute. So let's look at this question. Just a minute, everybody. Let's take a look at this question. Now, this is my question. Now, this was I want us to take a look at this structure. Take a look at that structure. Look at that structure. I want you to determine the number. Oh yeah? Determine the number. This question is in the pack. And imagine it's not looking like as if the R they were doing. Now, they said, I want you to determine the number of alkyl group that is attached to this alkene. So the first question is this. The page, okay, somebody is asking for the page. The page is page 143. Don't worry, page 143, but just look at the board, everybody. I'm going to give you a separate question. Page 143. Now let's go to page 143, everybody. But everybody, fix your eyes on this question, please. Where is the alkene that we are all concerned about? This is it. So these are alkene. This is the alkene we are all concerned about. Now I want you to determine how many alkyl group will you count for this compound. What I said about alkyl group, I said this is your target. This is your C, and this is your other C, right? Now trace it. It's attached to a carbon. You know it's attached to a carbon. Trace this one. Everybody, carbon. Now. Then trace it down here. It's also attached to a carbon. Now let me ask you a question. How many alkyl group will you say this guy is having attached to it? 4. Where is it? 1, 2, 3, 4. That is why I said, you know when I did this, I said C, and I said R, and I said what? R, and I said what? R. I said this one that you are looking at, this attachment that you are seeing is alkene. So in a real sense, don't disturb yourself. Just that, is it attached to another carbon? Do you get what I'm trying to say? So this R that you are seeing means that is it attached to another what? Carbon. Another what? Carbon. Another what? Carbon. Another what? Carbon. How many carbon is attached? This is like that. 4. Because it's 4 carbon that is attached to, we say it is 4 alkyl group. So in this case, how many alkyl group is there? Is attached to a carbon here 1. Attached to a carbon here how many? 2. Attached to a carbon here how many? 3. And attached to a carbon here how many here? 4. Do you have any question online? Oh yeah. Yes. Yeah. This is our target. This is the target. What is it directly attached to? Is what I'm concerned with. Is it directly attached to another carbon? If it is directly attached to, who is our target? These are our 2 targets. Can you see? Because they are the ones surrounding the what? The double bond. Now these 2 guys here. You look at it and what is it directly attached to? If it is directly attached to a carbon, you count it as one alkyl group. Is that okay? If it is directly attached to another carbon, you count it as another alkyl group. How many alkyl groups like that? 2. Here, 3. Here, 4. Do you all get that? How are we going to know the one attached to it? It's very simple. I said it again for those who are online. This is the 2 carbon that we are concerned with. The carbon of the alkene. Then look at it straight. What is it directly attached? There's a carbon here now. And look again, there's a carbon here. Look again, there's a carbon here. And look again, there's a carbon. How many carbon is it directly attached to? 1, 2, 3, 4. Because it's attached to 4 carbons from different angles, we can say it is having 4 alkyl group around it. Exactly. Now let me give you another one. Let me give you another one. Please tap on the like button. Let me give you another one. I want you to try this one if you will get it. Yeah, try this one. Okay. Try this one. How many alkyl groups do we have on this compound? That's the question. Is it that same question? Oh yeah. So everybody, what's our target? I'm thinking a new compound. Oh yeah. See a new compound. What's our target? Who said it's not clear? This is clear now. The C diagram. Okay. The C's are trans. Okay, don't worry. When we get there, I will explain. But I will explain it. Now, who? There's nothing here. Sorry, it's like this. Sorry. There's nothing here, it's like this. Now, everybody take a look at this structure. Where are we concerned with? We want to look at stability of alkene, Shebi. Where is the alkene part? This is the alkene part. It's not the ketone, sorry, there's no O here. This is the alkene part. Do you all agree? There's no O here, sorry, it's a mistake. This is the alkene part. Where are we concerned with everybody? Where is that C double bond C? I need you to show me where that C double bond C is. Where is C double bond C? This is C double bond C double bond C. Do you get it? You can put in everything. Here now, I know that this carbon now, you know it will have hydrogen. Do you know? What's going to surround this carbon? Because this carbon is not complete. It's having 1, 2. C. It's going to have how many hydrogen more? 2. 1, 2. Do you agree with me? Shebi? Oh yeah. Let's go. So my question is this. This is our C double bond C. How many? Check on this carbon. What is this carbon directly attached to? Oh yeah. What is this carbon directly attached to? It's attached to hydrogen and attached to another what? Hydrogen. Thank you. What is this carbon directly attached to? Those who are online, please pay attention. This carbon here, what is it directly attached to, everybody? Is directly attached to 1. This is a carbon, Abi. Directly attached to 1. This is a carbon, Abi. So how many carbon is like how many alkyl group do you say this guy is having? 2. 2 alkyl what group? If you check this guy, it's having just 1. Shemina, which is hydrogen and what? Hydrogen. Hydrogen and hydrogen will not be counted, right? This is our 2 guys we are concerned with, this carbon and this carbon. So when I look on this carbon, all I saw here is hydrogen and what? Hydrogen. Is that okay? When I look at this carbon, if you look down, it's connected to carbon. Abi? If you look up, it's connected to what else again? Carbon. Because it's connected to 2 carbon, you can say it's having how many alkyl group? 2 alkyl group. Is that okay? 2 alkyl group. Because it's having how many alkyl group? 4 alkyl group. Is that okay? Now, let's pick another one. Because that question, it was a particular year like that. You will tell me the number of alkyl group this guy is connected to. Now, everybody, let's take a look at this structure. Oh yeah. Thank you, Daddy. Now let's look at where's our C double bond C. Hello. Where's our C double bond C? In this compound now, where's our C double bond C? I want to see the C double bond C. Sorry. This is the C that is attached to another C. This is C double bond C. Do you all agree? Now, if this is the C double bond C, look at what we have here and what we have here. Then look at this carbon. So I'm going to be looking at this carbon and this carbon and this carbon is my target. Is that okay? Now on this carbon now, what do you see there? I can see it attached to something up here, which is another CH3. Do you agree with me? So it is attached to a C, which is 1. Now look at this carbon. How many things is this carbon attached to? It's attached to a C here. Then it's attached to a C here. How many C in total? This is 1C, 2C, and what? 3C. How many C in total? 3. That's 3C. If it is 3C, it signifies what? 3 what? Alkyl group. If it is 3C altogether, it means 3 alkyl group. If it is 1C, 1 alkyl group. If it is, did you get that? As simple as that. So this is how many that this is. I drew. This is 4 alkyl group. This is 2 alkyl group. This is 3 alkyl group. I'm going to give you something you are going to try. You don't worry. I think some people are already getting it online like that. This question came out in particular year, so I'm explaining it. Then we have 1 more to go that you tell me the answer. I want those people online to tell me this answer. Everybody online, you will give me the answer to this question. Okay, it's not the same thing. Everybody online, give me the answer to this question. How many alkyl group is attached to this our double bond? Everybody yet? Oh, you have to start doing it. Physical online, give me answer. How many alkyl group is attached to this our alkene? I want to see answer. Yes, it depends on the groups. Eh? Yes, that's correct. Someone is asking online that does it depend on the question we are doing is stability of alkene, and should be you all understand. That is depend. Everybody online is saying 1. Who is saying 2? Barakat Gilo Sele. 1 Mami. Barakat. Oh yeah, who are we concerned with? Should be stability of alkene we are doing now. And we are only concerned with this side because it's an alkene. Shebi. Now, where is the C double bond C? C double bond C. This is C double bond C. Shebi now. Then you now check on this our C double bond C. Now on this one that is this guy that is here, what we have there is H and what? H. Shebi you know. But what's attached directly to this our C that is here? The only thing that is attached to it is this carbon that is here. So how many carbon is there? 1. So can you see that this is C double bond C? On this C we have hydrogen and hydrogen, which we don't need. But on this C we have it directly attached to this carbon, which is signifying 1 carbon. Because it's 1 carbon, it's going to be 1 alkyl group. Yes, we are considering only the double bond because we are doing stability of alkene. So Clement, what's the question? What exactly is it that you did not get, Clement? Oh yeah. Now, based on what we've done here, I want somebody to tell me which of them is the most stable and which of them is the least stable. Clement, oh yeah, tell me where exactly are you not getting it right? Oh yeah, which one is the most stable, Jerry? The one with 4 now, the one that have 4 alkyl group. This guy is having 1, 2, 3, 4. Shebi. So the one with the 4 alkyl group. So if I say which one is the most stable, is the guy that have 4 alkyl group. Shebi. Which one of them is the least stable? What's the question? Which of them is the least stable? The one with what? Where is it? That guy here. Abi? Where is Clement? Clement, what's your question? Now, the reason this thing is looking somehow like this is because some of you did not attend the line when I was doing something on line formula. Is that okay? It's because if you understand line formula, the way I'm doing this diagram, it should not be difficult. Is that okay? Because I taught them line formula. The way you can convert a line formula to, is that okay? So some of you were not there. My other brother is sleeping. Hope you are fine. Let me tap him. Hello. Hope you are fine. Hello, Shia. Oh yeah, Clement. Is there any question? Where is that Clement? Now I'll give you a question. There's another question another year. Now, if I say most stable, I know I told you that the one of anyone that is the most. I said most stable means it will have less energy. Do you get that? Anything that is not stable the energy will be too much. But if they are very, very stable, your energy will be very less. That's chemistry for you. So a question can say, among the four of them, who is more stable? The guy that have 4 alkyl group, abi? Among all of them, who is having the least energy? Who will you say? The one of 4 alkyl. Do you get that? So, where's Clement? I did not see the Clement too. Now, let me put a question in another diagram on the board, and everybody will do that. If that is what we will do today, then we'll stop. Then another day we will go again. But this question on stability is very, very important. And in fact, we checked the past question. They didn't really explain it. They just picked the answer. Just pick the answer. So let me give you another one, and I'm going to ask that same question. So everybody gets ready on that one. We are going to look at another question. Yes, I've seen another one. Maybe another day we'll do stereoisomerism, so that I will not stress you too much today. So let's go. I want somebody to help me with this question. This seems as if it is the same thing. I think that year it was the same question. So you go should go to, I'm looking for a question for you. Let me see if I can find the question from your pack. If I can find the question from your past question. There are 2 different questions and I'm looking for it. There should be 2 different ones. Okay, we've done this one. Let me find another one. Okay, I think I've seen it. I want to see if you have really understand what I'm doing today. Once you understand, then we'll stop the class. Use another year. I think the structure looks like house. They can ask you to name it too. So math. Yeah, look at it. Oh yeah, people online. Where is how many alkene group is on this alkene? Where is the alkene? Target the alkene and give me the answer. Clement, oh yeah, Clement. How many alkene? Where anytime I give you a question like this, you go to the alkene, the C double bond C. Can you see the C double bond C? Yeah, people are already getting the question. It's 4, Jare. Adebisi, Omotola, Angela Oluwa. Some of you are not in my class when I was dealing with line formula. That's why you're having challenge with it. Where is the C double bond C? Can you locate the C double bond C? Where is it? This C double bond C. Once you first locate that place, it will make sense. Is that okay? Now, that's the C double bond C. Now, Clement, thank you. I think you have got this is the C double bond C. Now, trace this your C. Trace it. So trace this one, below and C, then to C, add 1. Trace this thing, send to this. This point is in C, you know. Another 1, you get that's 2. Now, let's trace this one that is there. They are tracing down. It's traced to this C that is there. Can you see? Then trace this one down. It's traced to this C that is there. So how many carbon is there? 1, 2, 3, 4. How many carbon are there? 4. 4 are cubed. Is that clear, Pathfinder? Yes. Is that clear? Yes. Now, this is one of the questions. I said something about the more the alkyl group, the more it becomes stable. Maybe you know. Now, people, this is for people online. In case you are sleeping, don't sleep. People online, I said the more the alkyl group, the more stable it is. Then I said, when it is stable, will it have lower energy or higher energy? I want to know if those who are online are following me. If your alkene is stable, very, very stable, will you have lower energy or will you have a very high energy? Yes, lower energy, less energy. So a stable alkene, we have a low energy. Is that okay? So in a nutshell, most stable will be the least energy. Say, write that down. Most stable will be the what? The least energy. The most stable alkene, we have the least what? Energy. Write it down, please. Everybody online, write that down. The most stable alkene, we have the least energy. Everybody tap on the like button, please. Tap. Oye TikTok la wà bá ti fún wa ní baby lion. All àwọn ọmọ tó máa ń gift mi ní orí kíní yìí. Where is that boy? Gonna move the baby. Where is Jabbar? Is Jabbar on this live?
Shout out to Benno, Mr. Jabbar.
Where is Jabbar? Kó tẹ baby lion fún mi o. Jabbar o wá ní. Where is Ayomikun? Press baby lion o. So let me give you another one if it's sure for you. Let's give another one. Another one. This question is coming from page 1. It is coming from your past question, page 108. Page 108. Now, let me give you another one and see what you do. Let's see what you will do. Another question is we are going to stop the class on stability. Our next class, I'm going to teach you isomerism. Is that clear? I don't want them to waste all their data. Actually, they are not wasting it, but some of them now have data. Those are issues. Those are one of the young data. Now, this is another one. This is another one from that question. So, yeah. Everybody, how many active group is attached to this our alkene? 3. I'm giving the answer. Sorry, people online, what's the answer? How many alkene group? How many alkene group is here? How many alkene group? Some people are saying 3 when I already answered the question myself. 3. People on physical distance, who is saying 1 now? 2. Who is saying 2? Oh yeah, let's see that. Where is the seed of bond seed? That's the question first. Everybody online, where is the seed of bond seed? Oh yeah, pay attention. Those who are picking to pay attention, let me teach you. Where is the seed of bond seed? This is the C. Double bond C. Can you see the seed of bond C? Now, if you look at this guy, he's attached to H, and he's attached down like this, going to this guy. Do you see where it's going to? Here. He's attached to this carbon 1. Now let's take a look at this carbon. Oh yeah, everybody, take a look at this carbon. Toyin, where's Toyin? Toyin, look at this thing. Toyin, are you just joining us? I hope you know. Now this is C double C. This is H. This is H. This C is connected to the other C. That's 1. Abi. Now look at this other C here. Count it for me. It's connected to a C that is up here. 2. Abi. It's connected to a C that is here. That's making it how many, everybody? 3. So it's connected to C. 1. For this one, 1. For this one, it's connected to 1. This C that is here. And connected to this C that is here. So that is making it how many? 3. 3 are cube. Again, Blossom, it is here. Blossom, have you eaten today? You don't understand them. Oh yeah, let's finish the question before we leave the live. Nobody should leave until we finish it. How many have I given you now? That's 2. This is compound A. Let's say this is compound A. This is compound B. Now, give me the answer to compound C. Let me give you another one. Give me 1. I'm giving you 2. And let me give you this one. Nobody should leave you. We are almost done. Abi, here's another one. Then, lastly, they gave you this. I don't think our class is up to 2 hours. I just think we'll do it very short so that you can go and have fun and eat and sleep. ẹlòmíì ti sáré délé ní owó ìṣòwò ẹ̀ lé wọ́n lè lé wọn lọ lé báyìí wọ́n ti lè lọ lé wọ́n ti sá lọ lé wọ́n lé wọn ìbò tí mo fi wọ́n ti rà wọn ẹ̀ wọ́n ti lè lọ lé kiri wọ́n lè fi sá lọ lé. If you are already in your house, signify, let me know. Oh yeah, this is compound A, B, C, then D. Oh yeah, let's do that C first. C, everybody, let's go to C. C. Now, C is this guy here. How many alkyl group can you see here? Clement, are you with me? Clement, oh yeah, don't worry, don't say hi again. How many alkyl group can you see here? This is C double C. Shemina is attached straight to one C here, one. Abi, this one is now attached to hydrogen. Yeah. Then this one is also attached straight to another C here, then attached to hydrogen. So how many C in total? 2C. Abi? Because it's 2C, that will be 2 alkyl group. 2 alkyl group. 2C means 2 alkyl group. Now let's go to the last one. This guy here. Everybody. For the last compound D, give me the answer to compound D. Compound D, everybody. Compound D. Compound D, everybody. Oh yeah, I'm waiting for not compound D. D is 1. Show me how it is 1. This place is carbon, Abi, and this place is your carbon, right? This carbon here is having hydrogen and is having another what? Hydrogen. But this carbon here is having its hydrogen and is now connected to a carbon that is here. There's a carbon here. Can you see a carbon? A carbon is here. So this is having hydrogen and hydrogen. Nothing is there. But here is having hydrogen. Then it's connected to a what? A carbon. So how many alkyl group? One alkyl group. So my question is this for everybody online and those who have come for the physical class. 1, 2, A, B, C, D. Who is more stable? A. Why is A more stable? Everybody, who is more stable? Option A, option B, option C, option D. Option A. Now, who is more stable? Option A. Why is option A more stable? Because it's having what? 4 alkyl groups. 4 alkyl groups. So today we've been able to achieve how to get stability of alkene. And I also taught them how to deal with cyclo compounds. Is that okay? Now, in the next class that we are going to be having, I'm going to be looking at isomerism, under which I'm going to see stereoisomerism. We are going to look at stereogenic center. There are questions that they give you a big structure, and they will ask you that what is the stereoisomer or the stereogenic center? Is that okay? So by now, we've been able to clear question on what do you call it? On stability of what? Alkene. If you see questions like this, you should be able to answer it. I'm going to send you assignments to. So A is more stable and is going to have the least what? Energy. Do you agree with me?
Yes.
A is the most stable and it will have the least what? Energy. So I'm going to send questions on the group. You people should ensure to do the assignments I'm going to give you. Then we'll be having our class again tomorrow. Math class we also hold. I'm going to send in information on when math class we hold and when physics class we hold. But for now, we might still be holding our chemistry. Then later we'll have our math class. So thank you so much. Do you have question for me? Do you enjoy today's class? Pharmjoe. Pharmjoe is the fucking chat. Oh yeah, tap on like button. Everybody, it's not easy. Celebrate Pharmjoe, it's not easy. Yeah. Tap. Where's Jabbar? Jabbar, you not press baby lion for me.
Baby lion.
Oh yeah, thank you so much for today. So we are going to see in our next class tomorrow. Thank you so much.
Woo!
The rest of the class.
Taking ended.
Wait. Yes. I appreciate the great man. It's not easy.
I don't think you shout.
Yeah, I bet. Do you enjoy the class? You can end it now. You can end it now. So you have to.
The only thing, except if you want to upload.
Okay, I'll upload it.